Hi and welcome to today's little video. Today I'm going to talk about GPS, and very specifically about GPS in space, and very specifically about GPS in space for our project, where we are actually in the situation that we have not got a low-cost GPS receiver to take with us into space. Those people that know something about GPS, they will know that there are, first of all, an issue with the technology where the commercial GPS receivers, which gives you the position, will not give position if you are above a certain altitude, and if you have a speed of more than a given speed, a fast speed I should add, done in order not to make it easy for a GPS to be used for military purposes. You can of course buy GPSs for space applications. They're very expensive, and you can buy them so that they don't have those restrictions built in, but that's a complicated process. What we really need for our project is a low-cost GPS which can be taken on board, maybe not ROMID 1, but possibly ROMID 2. So that's what I'm looking for. Now, several people have been working on that, a lot of people in fact, also at some of the universities, and one of the key issues for a commercial GPS to work in space is because the spacecraft moves so fast, it actually gives a significant Doppler shift in the frequencies, which gives troubles for commercial GPS receivers. Now let me try and illustrate what I'm really talking about. This was the closest I found to something that could illustrate Earth. And if we have Earth here and the satellites moving a fair bit out, the GPS satellites, something like that is their distance. There are 20-something odd of them, and they're moving around the Earth while the Earth is spinning inside. What a GPS receiver on the surface is doing is that it's triangulating between 3 satellites up here, and actually it needs a fourth to be sure, and from that it calculates in here the position. Now the position is on Earth's surface relatively stable, though it of course turns like that, and thus more other satellites comes into play, and these also turns around. Now if we on the other hand are in space, we are doing a turn of a little spacecraft which is doing like that, and if it's in a polar circuit it goes like that, and it goes very, very fast. And the problem is therefore that any satellite which it can see, for instance the satellite GPS up here, will have a very big relative speed. The spacecraft, those spacecraft will go here, this one will be hanging there, and the difference in speed will be such that this one will have a relatively large shift in Doppler frequency, and is therefore much more difficult to pick up for a GPS receiver. If on the other hand we have our little spacecraft, ROMID 1 or ROMID 2, circling around the polar orbit here, and we have, if the polar orbit is like that in this plane, the GPS satellite that's hanging out here will actually be able to see the spacecraft at all times. And because the GPS satellite is out here, it will have nearly zero Doppler frequency shift as it goes around, because the distance to this one is approximately the same no matter where we go. So if we go around fast here, 40 minutes for a tour, all those 40 minutes we will be able to see the same satellite and have the same distance to it, and we should be able to, with a simple GPS receiver, not trying to make the position but just decoding the signals, we should be able to get this satellite here. If you think logically about it, you will say that if we continue to go around that way, somewhere out here we will have another GPS satellite, which will again be fairly stable relative to our orbit. if we are patient people, and we are patient people, those two satellites in itself, if we know the position of this one and the position of that one, and we have a few measurements of the distance to our orbit here, then we would be able to calculate precisely our orbit and thus make a prediction of where we are. We're not looking for high precision in orbit. We are looking for maybe a precision of 1,000 kilometers, whereas on Earth you want to have precision of a meter on your GPS, but we don't care in space. Just knowing approximately where we are would be a great advantage, a significant advantage to not knowing. Now, there will be times when our satellite comes up here and goes around, where all the satellites, the GPS satellite here and here and here, has a very low Doppler shift, and if we take those into the equations and simply say everything that has a Doppler shift we don't care, and all those which have not, that will be the minimum shift will be when it's at a right angle to our orbit, and therefore if we can just pick up one signal once in a while, the computer on board will be able to do the rest for us. So this is really what I'm looking for. What I'm looking for is 2 volunteers on Earth, preferably that likes electronics, preferably that would love to play a little bit with GPS receivers, and maybe potentially actually simply with the antenna. Interface it to a microcomputer which we could have on board, and we are willing to provide one, and actually make a bit of hardware, not bigger than that, for ROMIT 2 in terms of a CubeSat. So, if you are that person, or if you know someone, or if you are at a university with any interest in something looking like that, a graduate student or an electronics course, somebody who would love to make a little bit of hardware and actually get the GPS to work and get the raw signals in and make a first attempt to get this position determined by excluding all the satellites except those that are, let's say, at the extreme positions rather than the nearest positions. So a philosophical point of view that's opposite to what is in all the GPS commercially available receivers right now. If you are that person, or if you know that person, send me an email on info@euroluna.dk. We are prepared to put on the cost of the hardware, and the rest will have to be something for fun, something that could be nice, something where you afterward would be able to say yourself, I have given a contribution to man's exploration of space, taking into account all the resources that's already available on the network, and there are plenty of them, but this job is to get a GPS low-cost flying. Thank you for listening.